In this problem, we're going to analyze a quadratic function with a positive leading coefficient. We want to analyze the function f of x equals 3x squared minus 12x plus 4. First thing we'd like to do is determine whether the graph opens up or down. We're going to determine that by looking at the coefficient on x squared. Since the coefficient on x squared is positive, we know that the graph of this quadratic function will open up. Next, we want to determine the vertex of the graph. We can find the x-coordinate of the vertex by using x equals negative b over 2a. We come back to our function, identify a is equal to 3, b is equal to negative 12, and c is equal to 4. We can get the x-coordinate is equal to negative 12 divided by 2 times 3, which will be 12 over 6, which is equal to 2. We can get the y-coordinate of the vertex by evaluating our function at x equal to 2. That is, we're going to find f of 2, which will be 3 times 2 squared minus 12 times 2 plus 4. 2 squared is 4, 4 times 3 is 12, 12 times 2 is 24, so we'll have 12 minus 24 plus 4, which is equal to negative 8. So the vertex of the graph will be the point 2, negative 8. Next, we want to determine the axis of symmetry of the graph. The axis of symmetry is a vertical line that passes through the vertex. The x-coordinate of the vertex we found to be 2, so our axis of symmetry is the vertical line given by x is equal to 2. Next, we want to find the intercepts for our graph. We'll find the y-intercept first. We'll find the y-intercept by evaluating the function at x equal to 0. F of 0 will be 3 times 0 squared minus 12 times 0 plus 4, which is just equal to 4. We could have found the y-intercept initially by just noting the constant in our function was 4, so our y-intercept is 4. Next, we'll find our x-intercepts. We'll find our x-intercepts by setting the function equal to 0 and then solving the resulting equation. Well, 0 is equal to 3x squared minus 12x plus 4. We identified earlier that a was equal to 3, b was equal to negative 12, and c was equal to 4. We'll solve this quadratic equation by using the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. We put in our values for a, b, and c. We'll have negative 12 plus or minus the square root of negative 12 squared minus 4 times 3 times 4 all over 2 times 3. So give us 12 plus or minus the square root of, now here we pay attention, we're squaring the negative 12, so give us 144, a positive 144. Then minus 4 times 3 is 12, 12 times 4 is 48, so we get 144 minus 48, all divided by 6. So we'll have 12 plus or minus the square root of 96 divided by 6. We can simplify this radical. We'll get 12 plus or minus 4 root 6 all over 6. We can cancel a common factor of 2, which will give us 6 plus or minus 2 root 6 all over 3. Now, if we put this into our calculator to get approximate values, we'll get x is approximately 0.37 and x is approximately 3.63. So our two x-intercepts are roughly 0.37 and 3.63, and our y-intercept was 4. In part E, we want to use the information that we just found in parts A through D to graph the quadratic function. After we've got the graph, in part F, we're going to use that graph to determine the domain and the range of the quadratic function. And then in part G, use the graph to determine where the function is increasing and where it's decreasing. So we'll go ahead and sketch that graph. We're going to plot our intercepts and the vertex. We found the vertex was the point 2, -8. We need to scale our graph. So we're going to go in the x direction, we'll scale by 1, so go up to 6, -6. In the y direction, we're going to go by 2s. We'll go down to -12 and up to +12. Our vertex was at 2, -8. So we go to x equals 2, go 2 units over along the x-axis. We go down to -8, but since we're scaling by 2, we'll go down to -2, -4, -6, down here to the point 2, -8. Our y-intercept was 4. Again, noting our scale is by 2, we'll have the point 0,4. We had 2 x-intercepts at roughly 0.37, about there, and 3.63. So that gives us the point 3.63, 0, and 0.37, 0. We found our axis of symmetry was the vertical line x equal to 2. So we'll draw our axis of symmetry. Notice that it passes through the vertex. This is our line x equal to 2. And we're going to plot one more point. We're going to use symmetry. We have the point 0,4 plotted. That's 2 units away from the axis of symmetry. So we'll go 2 units the other direction. And we can plot the point 4, 4. And then we're going to connect these points with a smooth curve. And there we have the graph of f of x is equal to 3x squared minus 12x plus 4. In part F, we are asked to determine the domain and range of the quadratic function from this graph. The domain is the set of all values for the input variable, in this case x. You can see from our graph that the domain will be the set of all real numbers, which in interval notation we would write as -∞ to +∞. The range is the set of all values for the dependent variable, which is y in this case. You can see that the smallest value for y will be -8, and we can get any value from -8 and up. So the range will be the set of all values for y such that y is greater than or equal to -8. In the interval notation, we would write -8 to infinity, using a square bracket on -8 because we can include that value. In part G, we were asked to determine where the function is increasing and where it is decreasing. And here we're looking for intervals for x values. You can see that the graph will be increasing starting at x equal to 2, and it will continue to increase as we move towards +∞. So we'll say the graph is increasing on the interval 2 to infinity. We'll see the graph starting from -∞ will decrease until we reach 2. So we'll say it's decreasing on the interval -∞ to 2. And notice that we're using parentheses on 2 in both of these intervals. When we do intervals for increasing or decreasing, we do not include the point where it changes because it can't be increasing and decreasing at the same time. So we use open intervals for these. So the graph is increasing on 2 to infinity and decreasing on -∞ to 2.